All right, our last section of word problems were pretty easy. They were proportions. This is a little harder. So it's going to use the ideas of rational expressions that we've learned, but I don't think you're going to like this one very much. The root of all of it is this. We need to see, do you remember that distance equals rate times time? That's the key to the whole problem. So we're going to use this idea, but what we really need, most of the issue is that we won't know time. And so if you were to solve this, so I should do it like this. So d equals r times t. Well, do you see that if we didn't know the time, if we rearrange this formula, which we learned how to do, time is distance over the rate. And so what's going to happen here is we're going to know something about the distance. We're going to know something about the rate. And we're going to use that and say, well, that, if you divide them, is got to be what the time is because they're equal. So this, d over r, is going to be the time. So let's get started here and we'll see what I'm talking about here. Okay. So what we're going to do, I don't know how much of this they've done. Okay, it's hard to jump between them here, but let's start with this. So what we need is we are going to set up this chart. And if you look at it here, what's missing? We don't really know anything about the times. So we're going to have some information about the rate and the distance. And what we're going to do is time must be d divided by r, like I've shown you on the first screen. Now let's go back here and let's talk about this a little bit. So what they're saying is this. Yeah, so here's what we got. I like to set up a little dictionary, and what I'm going to say here is r is the rate of the plane, the speed of the plane. Now, if the plane is in a vacuum, like it was in outer space, whatever, I don't know, the plane has its own speed, but the wind has a speed as well. So if the wind is working with it, so they're saying the wind is helping at 30 miles an hour. So I'm flying, I've got my own speed, but the wind is coming along and pushing behind me. It is helping me. So the speed of the plane is no longer just r, it's now r plus the 30 that we're getting from the boost of the wind. Now on the way home, what's happening is our plane still has the same speed, but it's now fighting against the wind. So our speed is slowed down by the 30. Okay, so we've got the rates, we've got the distances. So now going back to that chart, we have the rates. Here the wind is working against us. That's how far we can go when that happens. Now, the wind is helping us, and we can get this far. So we're going to set up this table each time. We've got our rates and we got our distances. Well, what does time have to be? Well, the time is the distance over the rate. Now, why do we need this? Because the only way to set up an equation is going to rely on this time column. We have to have it in order to make an equation so we can solve it. So what they're saying is that if we go back here, the same amount of time on both trips. Okay, so one more time through this. I'm fighting the wind, I can get 200. The wind's helping, I can get 300. Now, why did I set up this where I've just divided them? Distance over the time, or the speed. And the reason I've done that is because I need an equation. And my equation is I traveled the same amount of time both with the headwind and without. So now I have an equation. This was the headwind, this is the tailwind. Same amount of time lets me set them equal to each other. Now, where do we go from here? Well, this is now a proportion, and I would lasso these. Now, they've done it. Yeah, I need some space. We'll do it right here. So I'm going to lasso these. We've done this in several videos now. If you're not sure what I'm doing, so we're multiplying diagonally, go back. Okay, now we distribute. Now let's get our R's together. I'm going to move these over here and I'll have 100 R's. Send the 9,000 to the other side. All right, so what is the speed of the plane? Well, I'm just dividing both sides by 100 and I'll have it. So this is speed, so it's 150 miles per hour, whatever they told us it was. What's our unit? Yeah, miles per hour. So 150 miles per hour. Okay, now I know this is hard, but the idea is that we need time, even though it's difficult to set up, because that's where our equation is going to be. All right, so let's do this again. We've got I'm setting up my table here. Okay, so I don't like the terms, but the headwind and tailwind. So the headwind means we're fighting. So the wind is 3 miles an hour. So the headwind means it's fighting against us. So our speed here is x minus 3. So I should make my dictionary. This is our bike speed. That's what we want to know. So don't lose that. I make my dictionary so I know what I'm looking for. Okay, so we're fighting the wind, and sometimes the wind is helping us. All right, when we're fighting the wind, how far did we go? When we're fighting it, we went 20. And when it's helping us, we went 30. All right, now that's not very much, but what we have here, we know that time is going to be distance divided by the rate. So I can set this up. It's always going to be this. We're just setting those two over each other. Okay, why did we do it? Because we need time in order to set up an equation. Now let's see what it says. Same amount of time. The same amount of time with the headwind and without it. So now I have two equations that I can set equal to each other. So we're going to lasso. I'm going to run out of space here. Okay, lassoing this way and this way. All right, let's solve. I'm going to get the x's together. It's going to give me 10x. I'm going to do this in once. I'm going to send this way, and I'm going to send the 90 over. Okay, so this was our speed. This is what we're looking for, 15 miles per hour. Now, I'd really recommend, especially with word problems, you stop and try this on your own. But I'm going to fill this in. I don't like the terms all that much, but so tailwind means it's helping you. Headwind means you're fighting it. So we've got the speed of the boat. It's always the same stuff. Speed of the boat this time. Okay, so we're looking for the speed of the boat. So 7 miles per hour is the wind. So headwind, it's fighting us. Tailwind, it's helping us. Now, how far did we go each time? It's helping us, or fighting it for, we can get 5 miles. Helping us, we can get 12. Okay, now, time is always going to be distance over the rate. So let's just create this fraction, this rational expression. Okay, we got it. Now, we use the time to make the equation, and it's the same amount of time. We're going to see variations of this coming up, but okay, we've got it now. So let's lasso. Some people have their 12 tables memorized. I am not one of those people. All right, I'm going to send the 5x over the other side. I'm going to get 7x. And for the sake of time here, I got a lot of word problems. I'm going to add this. I'm doing this in one step, but it's just the algebra. Okay, now I'm going to divide 119 by 7. So x is 17 miles per hour. Okay, now I'm going to show you this. Working all of these is difficult. I'm going to show you the setup again. And what we're going to see, what we're going to see is that the setup is the same. Let me just get that set up and out of the way. What we're seeing is this. She runs, we're looking for, so this is my dictionary. And then she gets on a bike and she's faster when she's on her bike. Okay, so let's put this in our chart like we did before. She runs. Now she's not fighting the wind this time. She's just running. That's her rate. But the bike makes her go faster. Now when she runs, she goes 8. When she bikes, she can go 24. Now, we've done this before. We're going to need the time column, so we set up the time over the distance. That's what's happened right here. Now here's what's changed. Before, the amount of time running and biking was the same and we could just set them equal to each other, but not here. This is saying she spent a total of 3 hours out exercising. So what we're going to need to do now is this one plus this one must total to be 3 hours. So the initial setup is all the same, but what's changed is it isn't the two equal each other. It's that if you add them up, we get 3 hours. So we've got what we need here, but we're going to solve this, not like a proportion. We're going to do like we've done before, where this one needs an r plus 4. This one needs an r. And this one needs them both. Okay, now the denominator is the same. We don't need it anymore. We're going to get 8r. Now this is a little tricky. Well, not too bad. So we're just going to think of this as 3r and we're going to distribute it through. We're going to get 3r squared plus 12r. Now I'm not even going to write the denominator. It doesn't matter. So we're going to solve this by the zero product property, which means we need, because I have a square, I need a room to be empty. So first I'll put these together. So I'm going to just get everything over to this side. I'm subtracting 32r, and I'm subtracting 32. I'm going to write it like this just because we like it that way, but the same thing. I just sent everything over to one side. Okay, now we know how to solve this. This is not going to be an easy one. I don't see. Yeah, this is going to be the AC method, so this is not a lot of fun. Let's see how we can do with this. So I've got negative 96. So we need two numbers that multiply to get negative 96 and add to get negative 20. You know what? Let's let them help us. So they got here and they broke this down for us. So I'm not going to spend all the time in the video on the AC method. That's a hard one. You're going to be working that a while to try to find them. They must have done the trial and error method and they come up with this. So here are our two solutions. Now, so come down here. They have two solutions to this. One of them's a negative number. Well, obviously the speed can't be a negative. So what you'll find is that one of the answers when you have a quadratic, second degree there, one of the answers is meaningless. So that one doesn't matter. So the rate you can run is 8 miles per hour. Okay, let's try another one here. So I've got rate, time, and distance. So I'm going to call, I don't like headwind until we're going to, oh wait, hold on. I'm not sure that's the case. So let's see what we got here. Okay, so I'm going to do, so our speed, I want to call it x. Our speed is going to be his downhill speed. That's what we want to know. So we want to know his downhill speed, and here's what we know. So we're going to call this downhill. We're going to call this uphill. So when he's going downhill, that's the one we don't know. We know his uphill speed. That's fighting him. He's 5 miles an hour slower. Because we have our rates. Now, how far does he go on each of those? Uphill, he went 20. Downhill, he went 20. Okay, so time is always the two over top of each other, 20 over x, 20 over x minus 5. Now, I was expecting this to be the same. Oh, it is actually. So, yeah, it is. So, we were out and about exercising, this guy was, for 6 total hours. So, here's what's different about these. Now, I am going to add the 2 times, and they're going to equal 6. Total is 6 hours. Now, I'm going to make this a fraction. We're going to solve like we've been doing. I'm adding an x plus 5 here. This one needs an, oh, hold on. I don't know how to go backwards, so I got to start over. I needed an x minus 5 there. Here I needed an x. I was missing an x. And here I'm missing both of those. Okay, I'm definitely going to run out of space here, but we're going to distribute through them. The denominators won't matter. Where am I going to work this? Okay, we're going to tidy up. I need everything on one side, so I'm going to make this room empty. I'm doing this all in one step for time, but I'm moving the minus 40 over. Now that would add 100. Okay. Now here's what I didn't anticipate. These are brutal. Well, this actually has a GCF. That helps. So I can take out a 2. Pull out a GCF. That's supposed to be a 2. Pulling out a GCF of a 2. I'd have 3x squared minus 20x plus 35. Okay, all that equals 0. Now, the problem here is going to be the factoring. We got to come up with our AC method to find the numbers that will work here. And I'm totally out of space. I don't know if I can. Where am I going to do this? So this one's going to be brutal. So I've got 3 times 35. It's 105. So we need 2 numbers that multiply to get 105 and add to get negative 20. And so I'm definitely going to do my trick here, which is I'm going to break it down into its pieces. Oh, there's limited choices, so this might work out just fine. Okay, so if I break 105 down into its pieces, I get... So these 2 numbers both are going to be negative because of what I've done here. So go back to my old videos if you need it. But so they're both going to be negative, and they're going to add up to 20. So, and this does not work. So I've made a mistake somewhere. Okay, I actually did this whole thing over again, and I think their problem is incorrect. I can't find a mistake. So let's work another one here. I think something's wrong that I can't find that. You'd have to do something, the quadratic equation on that to get that to work, which is not something I want to do. I want it to be factored. So let's try another one, and hopefully we'll get this to work out. So we're going to do the same game here. Let's see. Okay, so I'm going to set up my speed. What is it we're looking for? It's his speed on the country roads. All right, so we've got our table. We're going to set up. This is going to be the country. This is going to be the highway. So country roads we said is I don't know. Now, what's his rate on the highway? He is 15 faster. Now, how about the distance that he's done on each of these? So on the country roads, he's on 40, 208 on the highway. Now, we always do this part the same. Our time is going to be that ratio. Going to be there. Okay, so we have what we need. Now, what are we doing here about time? We needed time, and we are going to go, he's 4 hours on the road. So that's one time, that's the other time, and he's on the road for 4 hours. So I should have done this a little better here. So I've got 40. This one is going to need x plus 15. This one is going to need an x. This one is going to need them both. Okay, let's distribute here. We've got big numbers again. So I've got 40x plus 40 times 15 gets me 600. Here I've got 208x. Sending this through, I get 4x squared plus 60x. You know what? I think I have a theory of what happened on my last one. I might have lost an x. I don't know. But this will work out. So let's keep going. We're going to get everything together. We've got just tidying up that left. Now let's come up here to get a little space. I'm moving everything to one side. So I'm bringing everything over here. Okay, so we've got it here. Now, do these all divide by 4? That would really make our life easier. It does. So we have to solve this with the zero product property, and that's going to be hard, but we can pull out a GCF. Okay, so we need two numbers that multiply to get negative 150. So they're going to have opposite signs, and they're going to add together to get 47. So let's do this. So here's my trick. I know it's a combination of these, all right? So, and thankfully this one works out. I have to group the numbers somehow to get numbers that we can add together to create negative 47. Well, it's right here. If I do that and make that the negative, I can get negative 50 and positive 3. So I'm going to finish my AC method right here. Okay, so I've got it. So I've got 4 times x plus 3, x minus 50 equals 0. So the 4 isn't going to be an issue here. We're going to get x is negative 3 and x is 50. All right, well, this can't be a real solution because we're talking about the speed on a country road. So the speed on the country road must be 50 miles per hour. Okay, I'm going to check real quick. I know this is long, but this is word problems. Let me see what we got left. Okay, one more type. So let's just work their example and then I'll do one more and we'll stop here. Okay, so what's changed now? We're going to set up our table. So we have down, this is, what's different about this? I don't see anything different. So we've got our downhill is what we're looking for. I don't know how fast he goes downhill. Uphill is 8 slower. So he's on the mountain for 12 miles, I guess, for each one. So we set up our table. Oh yeah, here's what we got. So he was 2 hours longer uphill than downhill. So setting up our final equation is going to be a little strange. So they've done it for us here. This is what we need. So this is, which one was he on longer? Uphill. Yeah. So to get these to about, look at our times here. So here's our 2 times. Now, if we want to set these equal to each other, then we need to add 2 hours to the downhill. Because he was 2 hours longer uphill, so we could have subtracted 2 from this, that would have worked. Or we're just going to add 2 to the downhill. So now these two things can be equal to each other. Okay, now we're doing this. This is the same approach we did before. He's going to need an r. They don't do it the same way, but it's the same result. This side needs an r. He needs an r minus 8. He needs everything. So we would both get down to this equation right here, where we could disregard the bottoms. We work all this out. We get our 2 answers, but this one's negative. Doesn't make sense. Okay, let's do one more of these here. So what we've got here is we're looking for Kayla's bike speed. Okay, we don't know it. That's her bike speed. Now let's set up our little table. All right, so her speed, here we got bike and we've got the bus. Okay, so the bike we don't know, but we know she's 10 miles an hour faster. Am I right? Every speed of the bus is. Yeah, she's faster on the bus, of course. Now, let's go, how far did she went? Each time, to and from college, she's going 75. So let's do our ratio column here, where it's always the proportion, or I should say the ratio. Okay, now, we have this column here. We needed the time in order to set up the story. And here's what we've got. It's 2 hours less on the bus. So we need these to match. So here's what I can set up. The bike took 2 hours longer. So I'm going to turn this into this. So the bike took 2 hours longer. So if I want to set these equal, I've got to take away 2 hours off of the bike so that these now match. Okay? So now they'll match because I've taken the extra 2 hours off the bike. Now let's set these up. Where am I going to do this? This one is going to need the x plus 10 on the top and the bottom. This one's going to need an x and an x plus 10. And this one is just going to need the x. Okay, so now we have common denominators. It's all matched up, so we're going to multiply through here. Now I'm going to take this 2 along for the ride. I'm sending minus 2x through here. I get negative 2x squared minus 20. And all this equals 75x. The bottoms don't matter anymore. Now, I've got 75 x's on both sides, so they're gone. This room now equals 0, and that's what I want to do the zero product property. But I don't want this to start with a negative. It makes it a little confusing. So what I'm going to do is I'm going to send everything to the other side, which just is going to just change the signs. I lost an x. Yeah. So I'm going to send everything over the other side. It's going to change everybody's sign, and I get this. Now, factoring this is going to be difficult, but I can pull out a 2 here. Okay, now we need to find the two numbers that multiply to get negative 375 and add to get 10. And I don't know them, so I'm going to do my trick. I think that's right. So here are my options. 3 times 5 times 5 times 5. I know they're going to have opposite signs because this is negative 375. And they're going to add to get 10. So let's look at our choices here. I can see it right away. I've got 25 and 15. If I make it positive 25 and negative 15, I'll get there. So I'm going to finish my, oh actually I don't need to AC method this. I can just go right to it. That'll work. Okay, now we solve this. 2 doesn't have anything to do with it. So we've got x is negative 25 and x is 15. But x being negative 25 doesn't make any sense. So we just need x is 15. And that is miles per hour. And that's the speed of the bike. Now these are brutal, but this video has gone on forever. So even though there's one more here, I'm going to just stop here. And hopefully that'll get you through.